Morning, nerds. Today we are going to finish polynomial division for now. We'll be using it a lot in the next chapter, but we're going to go ahead and finish it up today. Whee! I forgot. We didn't get to do this last example in class yesterday, did we? I don't even think we finished this example, did we? Well, we might as well go ahead and finish this one real quick. We got to here. Okay. So if you're watching the video in my first or my 8th period, you'll have to skip ahead a little bit. But anyway, we need to get this cursor off the screen. We need to, what did we do? We took this negative x because negative x is what it was going to take for us to multiply to get from here to here. So if we multiply 2x squared by negative x, we get to this negative 2x to the third, and that's how we chose negative x. At this point, we needed to get to this step using the negative x, so we have to distribute this negative x to our divisor. And that will get us negative 2x to the third. Negative x times x is negative x squared. Hey, look, it matches in 2 places. Negative x times 1 is negative x. We're going to subtract straight down. Anything minus itself is always going to be 0. So negative 2 minus negative 2, 0. Negative 1 minus negative 1, 0. 0 minus negative 1. That's addition. Anytime we have to say minus negative, it's addition. So we have a 1x here, and we drop down the negative 2. Can I divide x, no, excuse me, can I multiply x squared by something and get down to x? What numbers? No, they're not supposed to be there. These 2 numbers, I wrote them by accident. So there shouldn't be any numbers there. Anyway, no, I can't multiply something to this to get to this. The reason why? Because down here, the degree is 1. But my divisor is a degree of 2. The moment you get to a point where the degree is less than the divisor, you cannot continue division. You're finished. So that means this is our remainder. I don't really have the space to write that up here, so I'll write my answer over here. The result of this division is x squared minus x plus remainder over divisor. And the remainder is x minus 2. The divisor is 2x squared plus x plus 1. There. It's unfortunate that question was disjointed, but it is what it is. Let's do that last one. Now, yesterday I introduced the idea of no gap teeth smiles, right? You cannot have gaps in your polynomials. Correct? Right. From yesterday, this one was missing its x squared term and its x term right there in between those 2. So here we come to our dividend. See, x to the 5th, x to the 4th is missing. So we'll need that x to the 4th. X to the 3rd, x to the 2, x to the 1 is missing. So we'll also need a 0x. Your divisor also cannot have gaps in it. X to the 3, x to the 2 is missing. X to the 1, x to the none. There. So, I'm going to start writing it way over here because every time I've done this question, I've run out of horizontal space. So I'm going to start it way over here. My divisor. And, oh, if you watched yesterday's video, ladies, you'd see that I gave you both credit. So Allie told me that was an obelisk. And Melissa told me that this thing is a vinculum. And yeah. Don't forget those 0 terms. Oh no, I did it again. That number shouldn't be there. I moved over and I'm still almost out of horizontal space. Dang. Okay, now it's just the same as that we were doing before. We need to figure out what we have to multiply by so that this becomes this. What do we have to multiply that by to get 2x to the fifth? X squared, that's it. So that goes way over here. Take that x squared and distribute it to your divisor. X squared times 2x to the third is 2x to the fifth. X squared times 0x squared is 0x to the fourth. X squared times x is positive x to the third. And x squared times 1 is x squared. And we're going to subtract straight down. Let's see what's up. 2 minus 2, 0. 0 minus 0, 0. Negative 1 minus positive 1, well, that's negative 2. One minus 1 is 0. And then I'm supposed to drop down as 0x also? Weird. But here's the thing. My divisor has 4 parts, correct? When I multiply it by something and I write it down here, it's going to have 4 parts, right? So this is one of those times where you should probably drop down more stuff just so everything lines up properly. And you would have noticed because you would have written the 4 things and gone, oh, okay, wait a minute, and you would have brought the negative 2 down. So it wouldn't have caused you a problem if you didn't realize it up front. It wouldn't have been a big deal. Anywho, what do I need to multiply that by to get that? Negative 1, because I already have the correct number of x's. Negative 1. Now let's take this negative 1 and distribute it to this divisor. Negative 2x to the third. Yes.
X squared minus x squared.
No, it's not x squared minus, yeah, it gave me 0 x squared. 1 minus 1. Right here, you're wondering? This is 0x to the fourth.
How did you get 2?
How did I get 2 where? Right here?
Yeah.
Negative 1 minus 1. If you owe me $1 and you borrow another $1, you owe me $2. And I didn't bother putting the 0x to the fourth here because this has no x to the fourths anyway. If you want to, and it makes you feel more comfortable, there's absolutely nothing wrong with putting 0x to the fourth here and then saying, what do I have to multiply this by to get to a 0x to the fourth? The answer is 0x. So there would be a 0x here. And the gap implies there's a 0x there. But you never need to do that, okay? You only have to have the zeros if they're in between stuff, okay? So negative 1 to here, got me that. Negative 1 times 0 is 0 still. Negative 1 times x gets me negative x. Negative 1 times 1 gets me negative 1. And we subtract. Anything minus itself is going to be 0. So 0, 0 minus 0 is 0. 0 minus negative 1, that's positive 1. Negative 2 minus negative 1, that's negative 2 plus 1. But the degree down here is way less than the degree of my divisor, so I'm finished dividing. That means the result of the division is x squared minus 1 plus remainder over divisor. And you don't need to write the 0 term when you're writing your final answer. There it is. So you've seen long division with remainders. You've seen long division without a remainder. You've seen long division with gaps in the dividend. You've seen long division with gaps in the divisor. As far as I know, that's everything. I mean, that's really all the examples I could show you. Do you have questions about the long division process or what to do from there? No. Okay. then what we're going to do now is we're going to learn a shortcut method for division. I will never require you to use this shortcut method. I'm just going to tell you there will be times when you want to use it, especially next chapter. This shortcut method is called synthetic division. This example is the exact same example that we did yesterday at the bottom of the page. The first polynomial long division question we did. Here I solved using long division. So we see what our answer is. We're going to get the exact same answer, but this time we're going to get there using synthetic division. What is synthetic division? Synthetic division is a style of dividing that makes it so that you don't have to see any x's at all. Notice when I was doing this, I told you you had to hold your spaces open with zeros so your like terms would line up. As long as you do that, and I said it a few times, did you notice how I never said the x's? I always just used the numbers, the coefficients. Synthetic division deals with only the coefficients. You still cannot have gaps in your dividend. And if you do, those coefficients would be zeros, just like we did with the long division. You never have to worry about gaps in your divisor, because you should only do long division when your divisor is linear. If your divisor is not linear, can you do synthetic division? Yes. In fact, I'll show you how on the back of the paper. Do you need to? No. I'm only showing you because I would feel like less of an educator if I didn't show you. But you will never have to do it that way. It's only if you want to. In fact, when you're taking a test, I don't know what style of division you use. So as long as you could use synthetic or long division and get answers correct, I'm thrilled. Okay? One other thing that's different about synthetic division than long division. I've already told you we're not going to use the x's, we're only going to use their coefficients. The major difference is I'm going to use the zero of the divisor. What is the zero of this? 3. When you're doing synthetic division, you use the zero of the divisor only. Let's make sure we're not missing any terms. X to the 3, 2, 1, none. Good. We're not missing any terms. And here is how we set up. Here's how we set up the long division, or excuse me, synthetic division. Put this little box thing, and that is where you put the zero of your divisor. To the right of this little box thing, this is where you write the coefficients of your polynomial. 2, -3, -5, -10. See, we're not writing any of the x's. We're going to have a row of numbers underneath this purple row. Leave space for it, please. And then you see this little box? You're going to put a similar box right there. Remember, if you had a term missing, it would have been held open with a 0. That would have been its coefficient. Okay? What we do now is we bring this 2 down to here. I'm going to flip the paper for a second because I'm drawing parallels for you. Once we knew this 2x squared went here, what did we do with it? Like I put a 2x squared here, and then I immediately did what with it? I multiplied to the divisor, right? This is going to be the only example that I draw these green dotted arrows. It'll be the only example that I draw this orange downwards arrow because I'm showing you how this works. You take this 3 and you multiply it to the 2. Its result goes right here. And you add straight down. And then we will repeat that method until we're finished. So negative 3 plus 6 is 3. 3 times 3 is 9. Negative 5 plus 9 is 4. 3 times 4 is 12. Negative 10 plus 12 is 2. We divided a cubic degree 3 by linear degree 1. When we divide degree 3 by degree 1, what is our result? When you divide degree 3 by degree 1, what is the result? Degree 2. That means this is a second degree polynomial. This is a 2x squared, a 3x, a 4, a remainder. And it's finished. So fast, right? Synthetic division is much faster than long division, but it does have differences. It also has weaknesses. You cannot use synthetic division easily if you're dividing by something that is not linear. That's why in the homework, I specifically said only use synthetic division on ones where you're dividing by a linear term. Is it possible? Yeah, it's possible, but man, does it suck. It would actually require more brain power to do synthetic division than do long division if you're dividing by something that is not linear. That's not linear. You would not have wanted to try to do synthetic division with this. We could, but it's harder than the long division. There's just too many pieces and parts to keep track of. This is not worth it. And by the same token, if the 0 of your divisor is a fraction, let's say that was a fraction. Think about the multiplications and additions that you would have to do with those fractions. You might be better off just doing long division. But, I don't know. That would be up to you. And the one major difference, I used the 0 of the divisor and added instead of the actual divisor and subtracting. Do you see how when you get the 0, it's like the opposite of what you saw in here? You guys see that, right? That's why we're using the opposite operation. Because I'm using a positive 3 for the synthetic division, I have to make this subtraction become an addition. It's because I used the opposite of what I had here, so I have to use the opposite here. But look how fast that is. Of course you do. But it won't always be the better method. But when you see that you could do it, and you know it well, and if you're fast with it, go for it. Especially because in the next chapter, you're going to wish you were good with synthetic division. It's not a requirement, but man, does it make the questions easier. Okay, let's do it again. Remember, no gap teeth. X to the 4, 3 is missing. I'll need a 0 x to the third. X to the 4, 3, 2, 1, none. We're good. So when we set up our synthetic division, we're going to be using the 0 of our divisor. What's the 0 of our divisor? -2. And when we write out these coefficients, we'll make sure that there is a 0 between the 2 and the -3. Two, 0, -3, -5, -12. Oh, by the way, if we had done synthetic division with this example, because there was no remainder, there would have been a 0 in that box. And this box always encompasses the remainder. Okay? That's why it's there. So if the remainder is 0, let's just say that there was nothing here, the answer would have been that. And like I said before, you start by dropping that first number down. There. All right. Oh, I forgot my plus sign. To be honest with you, mathematicians don't write the plus sign. You just know that you're adding straight down. I'm only writing it because it's good notes. It's not wrong to write it. Anyway, -2 times 2 is -4. Adding straight down gets you -4. -2 times -4 is +8. Adding straight down gets you 5. -2 times 5 is -10. Adding straight down is -15. You know what else makes this so much easier? Because we're adding, we never have to worry about minus negatives. Do we? It's like literally just put the numbers together and see what you get. -2 times -15 is +30. And -12 plus 30 is +18. It is always assumed that this thing here is a constant. So that means this is a constant. This is x to the first, x to the second, x to the third. Or you could have looked at it and said, if I divide a 4th degree by a 1st degree, I get a 3rd degree. So that guarantees that that is 2x to the third. 2x to the third, -4x squared, plus 5x minus 15, plus remainder over divisor. It's fast, isn't it? It's easy. But again, you only want to do it when you have a linear divisor and preferably no fractions. Otherwise, long division is probably safer. Would you like to ask me any questions at all about synthetic division? Everybody's cool in the gang? Awesome. So I told you that you only want to do it when your divisor is linear. What if your divisor's not linear, but you still really want to use synthetic division? You still can, but it requires a special skill set and special circumstances. I've created a question that allows me to do this, but I had to create it. I'm going to show you on the back. and I tried to keep the numbers small. Could we attempt to tackle the synthetic division using a two-term setup here? Yes, you could. But I'm going to be real with you, I don't even know how. Because I would never even try. I've seen what it looks like, and I decided it's not worth that amount of effort. I'll just go to long division. Or if you know how to factor the divisor, then you could see its zeros, and you could perform synthetic division with the two zeros. You just do it twice. So again, I designed an easy question for me to show you this because it's not something that you'll ever have to do. What are the zeros here? Positive 1 and negative 1. Because this factors the x plus 1 times x minus 1. So it has two zeros. We're dividing by both of those things. Now I can't perform synthetic division with plus or minus 1. I have to choose one of them first. So I'll go with positive 1 first. Am I missing any terms? 4, 3, 2, 1, none? No, I'm not missing any terms. Mr. M, this is missing a term. Not if I'm using this. So I'm going to divide by that first. So I'm going to use x equals positive 1. Negative 3, negative 1, 3, negative 1. Okay, I'll drop the 2 down. 1 times 2 is 2. Negative 3 plus 2 is negative 1. 1 times negative 1 is negative 1. Negative 1 plus negative 1 is negative 2. 1 times negative 2 is negative 2. 3 plus negative 2 is positive 1. 1 times 1 is 1. And when I add straight down right there, something unique is going to allow me to keep working. I can only continue to move forward because I got a 0 here. If I had not gotten a 0 here, you would not be able to do what I'm about to do. Okay? So like I said, I designed it so this would work. Because there's a 0 here, I could do this. Now I can synthetically divide the orange setup by the other 0. But only because the original division got me no remainder. Drop the 2 down. Negative 1 times 2 is negative 2. Negative 1 and negative 2 added together gets me negative 3. Negative 1 times negative 3 is positive 3. Negative 2 plus 3 is positive 1. Negative 1 times 1 is negative 1. And once again, I got nothing. A fourth degree divided by a second degree is always going to be what degree? Degree 2. The result is 2x squared minus 3x plus 1. So if you divide this fourth degree by this quadratic, knowing it's two zeros, and the first one got you 0, you're allowed to continue working. Was it worth that amount of thinking and planning? What if that wasn't 0? I say no, it's not worth it. I usually would just said, screw it, I'm going to go to the long division. Just because I don't like to do work just to find out it was a waste of my time. But that's me. Anyway, in case you ever wanted to, boom, there it is, nerds.